they just can't use mine. You guys tired already on day 2?
Yeah.
Good morning, FHS. Today is Tuesday, November 28th, 2023. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
All right, welcome back. I hope you all had a nice, restful break. We have 6 more class periods together before a semester test. So 1 or 2 of those will be set aside specifically for working on the semester exam review and giving you a chance to ask questions. I will probably print that out and give it to you on Thursday. If you did not hear yesterday, this is a B week, so I will see you guys on Friday as well this week. So 3 of the 6 days that I see you before your semester exam will be this week. But we continue on and we do a couple more new things. You can see under the upcoming assessments, there's something called Riemann sums that we're going to talk about today. And some years we do like a 2 or 3 question quiz and some years we don't. So we haven't met yet to decide if we're going to do that this year. You'll see based on when we go over it today. It's nothing to really worry about, but you do want to make sure that you put in your best effort in case we do give you a couple point quiz on that. Semester exam, again, when you cannot exempt this semester exam, we require you to take it in fall, but we don't do one in spring, or we try not to do one in spring. So ours is on the 14th, but you guys should be checking, I guess, your student announcements to try to see what the semester exam testing schedule is this year, because it's a little bit different than past years. So what we're looking at today, in actually some of Thursday, is something called area under a curve. This is going to seem very uncalculus-like, but this is really a calculus topic. And before we even mention calculus, we've got some questions set up here to show you that sometimes you don't really need it, and it kind of shows you what the calculus is trying to achieve for us. So when a question says find the area under a curve, what that really means is the area between the function and the x-axis. So if I was asking you to determine the area under the curve of y equals 5, which has been graphed for us, from x equals 2 to x equals 6, then I would be asking you to find this area. Again, nothing to do with calculus yet. Bless you. And because that's a rectangle that is 5 in width and 4 in length, or whatever you want to call length and width, it would have 20 square units of area. Remember, area is always squared units. So when we talk about area under a curve, we're talking about the area trapped between the function and the x-axis. The first few questions have that typed out, but then it's just kind of implied. Okay, doing the same thing with y equals x plus 2 from x equals 1 to 4. So x equals 1 to 4. I would be interested in this area. So how could we figure out that area?
Splitting it into a rectangle and triangle.
Okay, so you could do a trapezoid. This is a trapezoid, and we will actually review the area of a trapezoid formula on Thursday because that's something else similar to Riemann sums. But for now, what kind of makes sense is just divide it into pieces that you know how to find the area of. This is 3 by 3, so there's 9 area in the rectangle. Triangle is 1/2 base times height. And that looks to be 6, I believe. So 6 in area, 9 in area, 15 square units total. That look okay? Okay. So again, no calculus needed. And if we keep going, now I'd like you to try questions 3 and 4, and we'll talk about how that applies to 5. So here's the function drawn for you. Question 3 is wanting you to find the area between 0 and 2. Actually, I lied. Let's do this one together. There's enough for you guys to do on the back. So find the area between 0 and 2. So that would be this. Again, let's just go ahead and do these together as well. So that's a triangle. So 1/2 times the base times the height. Looks like that would be 4 square units. But there's one big catch here, and I've typed it up right here. But just like values under the x-axis are considered negative, area under the x-axis is also considered negative. So this is taking up 4 square units, 4 units squared. But because that area is under the x-axis, we need to treat it as negative, as a -4. Just like y values below the x-axis are negative, area below the x-axis is also negative. And usually that's not marked for you. Usually you need to be paying attention enough to know that that needs to be negative. Okay, but then 2 to 5. Let's see, this would be another triangle. So 1/2 base times height. Should be 6, I believe. So 9. Yep. So 9 square units. And that area is above the x-axis, so it's a positive 9 square units. If my arithmetic looks off, please just speak up, because it's hard for me to focus on that part because I'm not real interested in that, but it is important, I guess. Okay, and now, point of this is, in question 3, we figured out how much area there was between 0 and 2. In question 4, we figured out how much area there was between 2 and 5. And in question 5, we want to know the full thing, the area from 0 to 5. So really, it's just like taking this part of the area, combine it with this part of the area, and overall it would be 5 units squared. So there's 5 more square units above the x-axis than there is below the x-axis. Again, if you know the area between 0 and 2, and you know the area from 2 to 5, you can add those together to get the area from 0 to 5. Okay, so still not really into calculus other than knowing that when it's talking about area under the curve, it's understood the area between the function and the x-axis, and I guess this idea of area being under the x-axis being negative, I guess that's probably the first time you've seen that in calculus. Okay, but here's where calculus starts to come into play here. Question 6, determine the area under the curve of x squared, which I've already graphed for you, from -3 to +3. So in the first 5 questions, we could split things up into triangles or rectangles, use the regular old geometry formulas that we're familiar with, and then we can piece those together. But you should feel like this is a struggle here because this has some curvature to it. This is not a triangle, so doing a triangle would not be the correct amount of area. Anytime you start to put some curvature in your function, now we need calculus. I can't just split this up into geometry shapes and add them together. Now, with calculus, we do 2 things. We estimate the area under the curve, which is called Riemann sum, and what we're going to focus on today. And later on, I'll probably show you, but we probably won't actually practice it much until we come back in January. But there's a way with calculus to figure out this exact area even with the curvature. And of course, those of you going on into a math or science career, if you're going to build a bridge someday, a car someday, your car's not going to be very aerodynamic if it doesn't have curved surfaces to it. If all of your stuff has to be sharp edges because that's all you know how to work with, you're never going to make anything that people want. So on the next page, I've got the same function, same -3 to 3, but now I'm going to tell you what a Riemann sum is and show you the 3 types you need to be able to do. Basically the same work, but they all start off a little bit differently. Okay, so each of these questions, we are going to estimate how much area is under this curve by taking the area of some rectangles and adding those rectangles together. That's all a Riemann sum is. If you can take the area of a rectangle, if you can do it multiple times, and you can add it together correctly, then you can do a Riemann sum. So, first off, you need to be told how many rectangles there's going to be. So that'll have to be given to you in the question. So I'm going to do 3 equal rectangles, 3 equal subdivisions. So I'm going to make my first rectangle here for each of the 3, and I'm going to try to color coordinate mine to help you see where these values are coming from. That would be my second rectangle and my third rectangle. So notice how those are all equal sizes, equal subdivisions. Okay, now here's probably the most important part. Well, actually, I'm just going to go ahead and make the blanks, because we're adding up the 3 rectangular areas. Okay, so here's the important part that you need to make sure that you see. A left Riemann sum means that for a rectangle, you go to the left x-most value, and wherever it hits the function, that determines the width of your rectangle. So you're going to draw that to the right, and our first rectangle is going to be 2 by 9, or 18 square units. Left Riemann sum, you take the left x-most value, see where it hits the function, and draw it to the right. Left x-most value, take where it hits the function, and then draw it to the right. So this one was 2 by 1, 2 square units, and this is 2 by 1, so 2 square units. So a left Riemann sum for this function, split into 3 equal subdivisions from -3 to 3, would have an estimated 22 square units of area. Now again, it doesn't really sound like I'm talking about calculus, but Riemann sums are considered a calculus topic. So just because the arithmetic is on the easier side, this is still going to be on one of your tests, and they put this on the AP exam. So that's all there is to it. So notice left Riemann sum, I took left x most value, drew to the right. Left x most value, drew to the right. Left x most value, drew to the right. So a right Riemann sum, I'm going to do the opposite. I'm going to take the right x most value and draw to the left. And the right x most value and draw to the left. And then the right x most value and draw to the left. Now, this one's just a coincidence. Usually the left Riemann sum and the right Riemann sum are not going to be the same value, but I can see that they're going to end up being the same here. This one is 2 by 9. This is 2 by 1. And this is 2 by 1. So, as long as you know how to draw the rectangles, you're just adding up the area of a couple rectangles. Sometimes 3, sometimes 4, sometimes 5, I guess. But that's the idea here. Okay, and then as you could probably guess, midpoint is going to determine the width of the rectangles in the middle. So this red rectangle, I'm going to take the middle x value, and wherever it hits the function, that's going to determine the width of this one. For the middle rectangle, the middlemost x value, wherever it hits the function, is going to determine his width. That guy has a width of 0, so he has an area of 0. And this one, the middle x value determines the width of the rectangle, so it would look like that. So this is 2 by 2, 3, 4. So this has an area of 8. This has the same dimensions, so I know it's going to have an area of 8. So a midpoint Riemann sum would estimate that area to 16 square units. Okay, and we're not going to get into today how to figure out the exact area, but takes me just a second here just to give you an idea of how good these estimates are. The exact area would be 18 square units. So somewhere between 16 and 22. Usually midpoint is a little more accurate. Usually the actual area is somewhere between the left sum and the right sum. But even though this is only 3 rectangles, these are fairly reasonable estimates, because notice on these, each one of these included some area that wasn't supposed to be part of the problem, like here and here. But then it missed some area that it was supposed to be there, like this. So this and this kind of compensate for that, and that's why it makes it a reasonable estimate. This is basically the same thing. There's a bunch of area that it computed that was not really under the curve, but then there was some area that was under the curve that it didn't and couldn't compute. So roughly this highlighted area covers up for that area, and that's why it's fairly close to the real deal. Over here, this one included a little bit too much area here and here, but it was missing a bunch of area here, a bunch of area here, a tiny bit of area here and here. So just an estimation. It's a reasonable estimation that we can do quickly by hand without a calculator usually, depending on what the function is. That's fairly accurate. So hypothetically, let's say I don't know any more calculus on this topic than this. What would make this more accurate if I really needed to be closer but I didn't have any other tools? What do you think?
More rectangles.
Sure, more rectangles. If you squeeze in 30 rectangles instead of 3 rectangles, they're all going to be a little bit closer to what they need to be. So in calculus, when we need it to be exact, How many rectangles will we use? What? We will. We'll do an infinite number of rectangles that are infinitely thin, and we will be able to calculate that. But that's for another time and date. Okay, I would like you to try this row as guided practice, but just one at a time. So here's x cubed. I tried to pick out numbers that are not too messy, -2 to 2. And I want 4 equal rectangles, and do a left Riemann sum. And then we will check it to make sure that there's not something you're overlooking. Make corrections if need be. And then we'll do guided practice on the next two also. One for right Riemann sum, one for midpoint Riemann sum. Well, it's going to be the exact same thing as this. It's just that some of the numbers are going to be fractions. These two will be fine, but this one you're going to have some like figuring out this exact y value. You're going to have to plug in this x value into the function. Some of those are decimals, and that's why we didn't calculate that last one. I don't think there is. Okay. Okay, so I tried to sketch the 4 rectangles here so you can visualize. I almost made a mistake on the third one, and I did the same thing yesterday. So you have to be careful. Left Riemann sum, left x most value, draw to the right. Left x most value, draw to the right. And then on this one, left x most value, draw to the right. Left x most value, draw to the right. A common answer is going to be, let's see, this is 8 by 1. So some people are going to put down 8. This would be 1 by 1. How much area did the third rectangle have? 0, because it had no width. And then this one was 1. This whole thing is 1, and this is 1. So it had an area of 1. So I would expect some answers of 10, but why is 10 not going to be correct? Mason? Which one?
8 and 1.
Good. This stuff is below the x-axis, so you need to consider it as negative, and this stuff is below the x-axis, so you should consider it negative as well. So actually, -8 square units. Again, no one's going to remind you the area under a curve is negative, and area above the, area under the x-axis is negative, the area above the x-axis is positive. You have to keep that in mind with each question. Okay, so if you can do that one, the only difference with question 8 is how the rectangle is set up. So now it's a right sum, so if you would go ahead and start that one if you have not yet. And give me a minute to do it too, plus a minute for you to finish, and we'll make sure that we're okay there. Okay, your far left rectangle should be 1 by 1, but is below the x-axis, so -1 area. Your second rectangle was 1 by 0, so 0 area. Your third one should be 1 by 1. Again, I know that 1 tick mark horizontally is much bigger than 1 tick mark vertically, but it's still 1 by 1. It's above the x-axis, so that would be +1. And then the last one was 1 by 8. So in the end, 8 square units. Everybody okay with that one? Okay, then one more at my pace, and then the stuff on the next page is the same stuff, although one of them is a little messier and you'll need a calculator for. And then the back page, instead of being a function or a graph, it's in a table, which is usually how your AP test does it. But I will let you work at your own pace after we check this one, and then I'd like to come together at the end and talk about question 4 and 5 on the back page as a group. Okay, so before I even do the arithmetic, can you see what the answer should come out to be? You said 0? Yeah, I agree, because just the dimensions of this and the dimensions of this are equal to the dimensions of this and the dimensions of this. This stuff's above positive, this stuff's below negative, so I know the answer is going to come out to be 0 square units, but when you do an FRQ and when you get to the back page, it's like a practice FRQ, you'll see that they expect you to show this. This is your calculations that leads to that. So this was 1 by this, and so this would be when x was negative 1.5. Cube that would be negative 9/4 for that. This should be the same, 1 by oh wait, that's cubed, my bad. Not, I thought it was squared. This is negative 3/2. If I cube that, that would be negative 27. 3 times 3 times 3 would be 8. Negative 27/8. This would be the same thing. 1 times positive 27/8. This would be 1 by, let's see, if I plug in negative 1/2 and cube it, that would be negative 1/8. And then this has the exact same dimensions, so I can cheat a little bit and reuse that. But you need to take notice that when you're doing midpoint, oftentimes the y value, the width of each of these, is likely not going to a nice whole number. So the way I was coming up with 1/8 and 27/8 is I was plugging those x values into the function and solving for y. And knowing the y value, where the function hits, determines the width of each of those. But there's just as much area as above the x-axis as below the x-axis. So a midpoint Riemann sum would estimate that area to be 0 if you did 4 equal subdivisions, and if it was x cubed, and if you were going from -2 to 2. All of that stuff can change though. So the main thing I need you to get out of this one is, just because you're adding the area of rectangles together, and you can do that as long as you're careful, especially on midpoint ones, be careful with the width. It may not be a nice whole number. You may have to plug that x value into the function to solve for the y value. Okay, so on the next page, I would like, this is the same things, just a little harder function. There's a left sum, a right sum, and a midpoint sum. The left sum and the right sum should work out pretty nicely, but your midpoint sum, you will want a calculator with this one. There are some decimals or fractions like the last one I just went over. So I would like you to do those 3, and you're welcome to check with your group that you're sitting around to see how you're doing. And I would like to visually see and confirm that those are okay today. So go ahead and start on that, and then once you get the okay for me that those are okay, you can move on to the practice FRQ on the back. And I would like to also check those, but the last 2 on the practice FRQ we'll discuss together because it's an extension. It's talking about why you would care to know the area under a curve, what the area under the curve could represent, how you could know the units, stuff like that. So I want you to give it a shot on your own first, but I need to make sure that we're all on the same page there too. can't find my answers from page 3 from yesterday, so it'll take me a couple minutes. I need to work them out again before I can start checking y'all's. think you are done with those three. Let me come check, please. I get a difference from this one and this one. That one's really close.
This one, I'm not sure how I need to use it later. So, like,
Well, because when you're counting this right here, you're estimating what the y value is.
Yeah.
And those are off a little bit. Those are
Yeah.
not, these are hitting exact values, so these are fine.
Mm.
This one's off a little bit though. That's close. That is right. So like define this width, you need to know the y value of x is -7. So you need to plug -7 into this, and it's some decimal. It's close to a whole number, but it's not exactly a whole number.
okay.
It's just, look at that one again for a minute. We'll talk about the last one together, but I don't wanna just immediately give away what the answer's supposed to be. Yes? Oh, okay. That's right, that's right. That's right. Take that one off. That's good, that's good. Times 3. I'm gonna check your answers just to make sure that if something's wrong. Okay, let's see. These you need to read the directions. You gotta show where your work's coming from. You don't have to graph it, but you need to show where you're, like what you're adding to come up with those numbers. This one's close, I got a different number. Looking back at this one, for sure.
24, 12, 6,
Yeah,
and
that's correct.
16.
Or at least that's what I got.
Is that the one?
Unless I made a mistake.
I got 24. Or 22.
On these, none of this is negative. I know this looks like the x-axis because it's bolded this line, but the x-axis is way down here. All of it is x-axis. Let's get it right there.
That's good. That's good. Yeah, that's good. Yeah. You do better on that. And also don't forget the first test. Yeah, so like I got like 85 on the first test, I got a 95 on the second test. So it so I would be really bad. But since we had a break, I got a little bit, but yeah.
What did you do wrong? Oh, well, I didn't find anything about you yesterday. My answer was happened, but everybody else did. Yep. Again, after I check your page 3, you're welcome to move on to the last page. You don't have to do the last page on the graph paper like it says, but you do need to show where your answers are coming from. I'll just give me an answer. Write down what you put in your calculator. One sec. Okay. Yes, yes, and yes. You can move on to the last page.
-7 for heck. What about the chart? So -7 and then we do. gonna talk about the last two.
We could, but you're gonna try to see what you
I
can
don't know
do.
what to do with the calculator.
Well, where's your first rectangle?
Here.
Okay, what's the width of your first rectangle? Okay, what's the length of your first rectangle?
No.
Did you say 2 on the first one?
Yeah, this is.
This is, hold on, this is not the x-axis.
Oh, shit.
The x-axis is way down there. It just bolded that line a little bit when it printed. There you go. So your length is the same thing as the y value when x is negative 7.
Yeah.
So you need to plug -7 into that function,
Mm-hmm.
which is gonna give you a decimal, but that's the length of that rectangle. Times it by 2, and then you have that area. Do it 4 more times, and then. I'm sorry? It just means like when you're talking about this area, you're given these answers, what do these answers mean in context of this question? Like what's the real world application that it's referring to in this problem? The area represents blank. We're gonna talk about it, but just give it a shot on your own first. You need to wait for everyone to get there.
Okay, so that's what it starts. The lead broke, but I've never seen it break this far down.
Yeah, you may not have much of a pencil by the time you sharpen it, but
Quite surprised.
those are all right, but after you thought about this, I'm not going to look at it.
Did you grab it in your calculator or this? And that's it.
And then you hit for X.
So,
You just arrow back up to it. And then your X is stored for the correct bin, so every X can have it. It's very convenient.
So you need to go back to, you got 24. And that's why all that.
Yes.
And 1. Yeah, I got 11. Because you plug in negative.
You multiply it by 3.
-5, 3.
This becomes 20. Carry the 2.
Wait, no, that's.
Then multiply this.
That's negative 4.
15.
Wait,
But then
what?
break down the 2, 20. Carry the 2, and when there's a 0. So it's the same. Carry the 2, 0. Carry the 2, 0. Again, equal out to 0, and then 1. So 8 out of 6s and then a 7 is equal to 1. Or it's equal to 1/3. So multiply that 8 out of 6 and 7
yeah.
by 3, and you get 1.
I'll just say it.
I would say as you approach it, it goes to 1.
I mean, you wouldn't say that if you done something
But this is-
by 3 would have approached 1.
Right, but 1/3 times 3 is of course 1.
This times 3 equals 1.
No, this is, well, okay.
Somehow
it's
lizard
not
wants it.
It's in the other direction.
Yeah, the thing is, it only works in non-prime cases. This does not occur in like base 30 or base 11. It's only in like, it's only in non-prime cases that this sort of thing occurs. Yeah. The entire field of math based on it, it's really
Yeah.
cool.
Those look good now. That one's really close. Moving the decimal. Look at that. That's good, that's good, that's good. Did you come up with the answer in the last one yet? See the window settings. Someone's messes up. See the Y min and Y max is 10, so it's not opening up at all, it's not showing anything. So you can manually change those, or if you do Zoom 6, which is the second standard.
12.375. And then
Yeah, you can turn on the back page, but I'd like to check your third page first.
3.875. And then 4.25. Okay, I didn't put it How did you last day to my attorney? I feel like
So I didn't put it as a hazard, this was a full year. Sounds like this one is like 0
I don't watch it very often. I have to be careful about watching the videos I watch.
Yeah.
I'll be like stuck on it for weeks. Thinking about it.
9.5 times 10, that's
Those are good. You're not sure about them, 5?
4.5 times 2.4 times 10.
You don't have to do that. You want it separate sheet of paper, you want you to- Yes, 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 that's good.
I was no, yeah. Okay. I just like couldn't figure out. I was like. Also, I was really paying attention to the
Not that. What's this one? Oh, right there. That's right.
Yeah.
Okay.
Is it this? Oh, where'd it go?
I should have a decimal in the answer. That is pretty close. You're less than 10 off.
Did you like plug it in for all of them, or only for the ones that it looks like it matches good?
Well, I plugged it into all of them because none of them match up perfectly. Like up here, it wasn't an issue because like when x is -8, y was an exact whole number. And if you were unsure of that, well, I guess left sum would be this one. If you weren't sure of that, you could plug -8 into this function to see that it's 2.
Okay.
But down here, it's decimals every time.
Is mine right?
The last one is, yep, that's when you move on to the last page. I will also check the first 3 on the last page for you if you are
Okay, so it's showing me-
working quicker than everybody else, but I want to save the last 2 as a group. Agree with these 2. That
Just
one
scroll
has
to where I was.
I don't get it.
Oh, okay. Just like enter on it and bring it back down. And then just click enter. So now it's down at your bottom, so that you would store X for.
Is it what's what I put sort?
You have to type it in the same place, so it'd be like 9 store X. Store.
Oh wait. Okay, I was trying to so you put the one.
Yes.
Why don't we-
Then you go back to where the equation is and you just read it through. Yeah.
You'll have to grind it first.
You don't have to. It might help you if you're a visual person, but it's also just got all the information you need right there, so you should try to see how to use it without making a graph.
But you did the zero.
Okay, yes.
Yep, that's right. The units are not right, but the report's gonna try to get you to think about units, and we're gonna talk about these two together, so you can go back and correct that after the fact. I agree with this one. These two look switched to me.
Okay.
I might make sure it wasn't
Oh,
because
yeah.
of the directions.
Yeah, it was.
Yeah, when you guys get to that last page, don't assume it's asking for left sum, and then asking for right sum, and then asking for midpoint. They can be asked in any order. I have no idea. It's not the right answer. It's still about 10 off. So if you're not sure what to change, just hang on a few minutes. We're getting close to kind of being at the same spot here, so I'll interrupt here in a few minutes so that we can discuss some of the last stuff together.
What did you say?
Although the units will come back and be more specific once you think about question 4.
Squeeze that right. Yeah, so say you
Which
got,
one?
so you got 100 on this, we'll also get us
Yeah. It's in the right range, but you're about 20 too short.
I feel like this one is definitely wrong.
Okay, I agree with that. This is good, this is good.
Are my units on?
No, the units are not right.
Okay.
I feel like with the table, usually midpoint is kind of a pain, like you saw in the
Yeah.
picture. But when they give you a table, I don't feel like it's any harder than the first two.
Maybe I just don't understand midpoint at all. That's okay. I'm just doing this.
Okay,
I wasn't doing
I want to talk about page 3 for just a second here. So if there's something about page 3 that's holding you back, you can get a couple quick hints. I'm not going to give it all away because I want you to stick with it here. There's not a ton of practice. But on page 3, your first answer should be 70, 80, and then the last one, this is why I said you needed a calculator. The last answer on page 3 should be 76.25. And where that's coming from, you can see all of my rectangles are drawn to the midpoint of each one. But what makes these harder and why a calculator is needed for the messiness of this is this red one. The length of this rectangle was the y value when x was -7. So I plugged -7 into the function, into my calculator, and got 9.125. So the length ended up being 9.125, the width ended up being 2, so that was the red rectangle. For the second one, his length comes from the y value when x is -5. So I plugged -5 into the function, saw that his length was 12.375, multiplied him by his width, and that's how I got the length or the area of my purple rectangle. Okay, I'll verbalize one more time. This one, this guy's length came from the y value when x was -3. So I had to plug -3 into the function, hit enter to solve for y, and the length of that third rectangle was 8.625. I know some of them look like they're hitting nice even numbers, but they're not hitting nice even numbers there. When that happens, like the left sum and the right sum from earlier, then that's great. Take advantage of it. But in this case, those links were not nice whole numbers. All of those had some weird decimals, and that's why I was pushing to use the calculator. So, from page 3, if you did not get 70, 80, and 76.25, you should jot the right answer out to the side, and you can come back and give it another shot here in a little bit. You'll have some class time to work on that. And then I'd like to talk about the back page for a moment. Hide some of this. Okay, the back page is in table format. And honestly, this is probably the most likely way you will see this in the future. This is how the AP test likes to do it, because they can easily ask you to do a midpoint sum and not expect you to get out a calculator and not expect you to mess with messy decimals like that last question. All the information's right here. But for all of these questions, this is supposed to be 4 equal subdivisions. So you can graph it if you want to. I told you that part's optional. But to me, I can visualize 0 to 10 would make up my first rectangle. 10 to 20 would make up my second rectangle. 20 to 30 makes up rectangle number 3. And 30 to 40 makes up rectangle 4. So you don't have to draw those in, but I can visualize where rectangle 1, 2, 3, and 4 is. So if I need left sum, I know I'm looking at left values. If I need right sum, I'm working with right most values for each rectangle. And when you need midpoint sum, you get to use the value in the middle. And again, that's actually helpful that it's in table, because the left value, the right value, and the middle value is all right there in the table. You just have to decipher that information. So, same thing. I'm going to share the first three answers with you, and if you don't have those answers, you can retry them and get your work to correct those. But go ahead and jot them out to the side. You do have to show the arithmetic that goes with those. So 237, 234, and 229 are what we're aiming for the top three. And you can see my arithmetic there. Length times width, length times width, length times width, and length times width. I'm adding up 4 length times widths. The widths were all 10. The lengths all came from the table. Either the leftmost value if it was left sum, the rightmost value if it was right sum, or the middle value if it was midpoint sum. Okay, but I want to go ahead and talk about 4 and 5 together because we did not talk about these in the notes, and this is some stuff that they expect you to be able to refer to. Question 4. Using correct units, explain the meaning of the approximation of the area. So area is not just some abstract thing. Area can represent lots of stuff. So what do you think the area is in this question? What does area represent in this question? Okay, more specific than distance. Okay, distance in miles. How did you know that?
Well, if it's just a rectangle, if the graph's just a rectangle, then the distance is the length of time times the miles. So that just turns out to be the area of the rectangle. So then if you split the graph into different rectangles,
Okay. So I think his reasoning is similar to my reasoning, at least the first part was. Each of these are just rectangles, length times width, and if you know what these units are, and you know what these units are, length times width, do you see how the minutes units cancel and leave you miles? So for this particular example and this data, each one of these area represents the miles traveled by the plane, airplane. Length times width, just multiply the units together. The units of length times the units of width, get the minutes to cancel, and you are left with miles. Area represents miles in this question. So again, it seems abstract, it seems like made up values, but being able to estimate those areas, we can estimate how many miles the airplane has gone after 10 minutes and 20 minutes and 30 minutes and 40 minutes because we know his speed. Okay, and then the last part, this seems to be maybe the hardest, but it's kind of understandable. What's the smallest number of instances? So the number that we are sure that this happens where the acceleration could be 0. So how many times are we sure that the acceleration is 0? So to answer this, you need to remember that acceleration is the same thing as the derivative of velocity. I have to make that connection because they only tell me about velocity here. And they didn't give me a function that I can take the derivative of. So what's another way to think of derivative? Slope. Okay. So if I don't think making a graph was really needed for the first 4 questions. However, it does take about 30 seconds to just make a quick sketch, roughly plot those points. Try to hide this. And now, of course, I don't know what's happening between 0 and 5, but I know it starts here and ends here. I don't know what's happening between 5 and 10, but I know where it starts and ends. So I can make some reasonable assumptions about what the graph is going to look like. And the table is giving me these values. So if acceleration is really just the derivative of velocity, and these are velocity graphs, and derivative is the same thing as slope, how many times is the slope guaranteed to be 0? it has to happen at least once down here and at least once there. You see how the slope during those instances is 0? Slope of velocity is the same as acceleration. Acceleration has to be 0 at least once here and at least once here. So we are sure that the acceleration is 0 at least twice. Now, you need to word that in a way that makes sense to you. The reason why we say at least twice is because it could happen more times between like 5 and 10. I don't really know what's happening between these values. So in theory, you know, it could be 0 and I just don't see that, but there's no way for us to know that. So we can only go on what we have. It has to be at least twice. So again, not new, but just connecting that acceleration is the derivative of velocity. Derivative shows up as slope. If you make a graph, you can quickly glance at it and see how many times the slope has to be 0. It has to be 0 at least twice. Okay, so go ahead again. I'd like you to put some sort of an explanation that will help you remember that so you can look back at this. And if you did not end up with answers 237, 234, 229, jot those out to the side and try them again until you can see what you were doing incorrectly. And then I will come around and help. Yes, Julie?
How do you split, like, you know how 0 to 40 is like, like 9 sections? How do you split that into 4 equal parts?
Like this.
So you can overlap them?
Well, they're not really sharing this. Like at 10, it stops being my red rectangle and starts being my purple rectangle. Same thing I did here at x equals -6. Not only was that for my first rectangle, it was also the start of my second rectangle. So it's not like it's really overlapping, it's just that they share that one value. And again, there's nothing wrong with making a graph. It says to make a graph, and honestly, if you're a visual person, you should probably make a quick little sketch like this. And then you can do the left sum, right sum, midpoint sum. If that visual helps you, usually I feel better with the visual too, then of course do that. No one's going to stop you from doing it. Okay, so I will come around and help if you're absolutely hard stuck and you don't know what else to try. Otherwise, you guys have about 12 minutes. If you cannot get those correct answers and work behind those correct answers in class, then that will be what your homework is. But no homework otherwise.
Yeah.
Did you get what you needed on midpoint on that?
Yeah.
Yep.
This was like a test. How would you? Would that be okay?
I don't know what brand they are. We should have calligraphy because I've always seen them.
Well, it doesn't ask you to say when. I would say 2.
Like acceleration, 2 times, at least 2 times.
I would say if you're going to refer to anything, I would refer to these two. See how velocity is the same? So if it was speeding up in between them, it must have slowed down somewhere too. So if it was speeding up and then slowing down, there's a time where the acceleration is 0. And then same here. If these are the same, it probably didn't reach 2.4, say 2.4 for whatever, 5 minutes exactly. So it probably, or even if it did, it would be an acceleration an infinite number of times. But we're sure that it at least did 1 time. So if you're going to refer to times, it's got to change somewhere between 0 and 15, and at least once between 25 and 30.
Okay.
My eyes is track. Dirty track. I have an 8 in Spanish, which is crazy. I know. I don't know what
Okay, does anybody need me to combine help?
Is this a new one? You're just gonna be able to show me.
Otherwise, you guys can just discuss that.
There wasn't just any. It wasn't very bad.
They don't allow that.
Actually, calculus is one of the worst ones too, which is there's AB topics and BC topics.
That's what I remember.
And BC students also participate.
Also, like, since I do pre-cal, like,
You're at a disadvantage if you take
I
BC.
do not know it.
Are you talking about that Thursday?
Yeah, there's like one,
I did it last year.
I think that I have.
Good.
There's different ones
I
that we
placed,
get,
I
but there's,
placed.
there's one right. There's one that I have like regarded. And like,
Dude,
I did it
asking
in
me, I
like
don't
algebra
remember.
too.
Really?
I know, like,
It was fun.
it was like during COVID, we had to miss some of that point.
Like I placed them all 10 and then the
I know it.
tiebreakers like got me right
The
down.
tiebreakers comparatively.
You know, most people who do really well at that though spend like hundreds of hours practicing and
Oh,
studying.
really?
Yes.
I just. Yeah. I haven't heard anything back from Mr. Russell, but I think I already missed it.
I think if we, I think if we, did it else if we talked about it. On my plan, it's like 2 pages is 1 month. So it's like November, December.
Did anybody have anything exciting happen over the break?
November.
Just regular stuff?
I saw a shark
November.
when I was snorkeling.
And then like, this blank days are so that's scary. And then
I'm guessing it was a harmless one?
Yeah.
it looked like 3 weeks and then.